This will be a sort of fairly brief presentation, just covering those 4 parts there, really. First of all, just a little bit more general introduction about thermos and how it might apply to its use within a city. Then we're going to look at decision makers' involvement, and then look at how it may impact job roles and integration within a local authority in the different parts of that local authority, and then a little bit about different stakeholders that thermos may be used by. So on to the first part there. Hopefully all of you have by now had a chance to have a little play with thermos. We had the webinar, the first one 2 weeks ago, where Tom, my colleague, introduced it, and as you know, the tool is now available online, and anyone can log on and have a look at it and have a play, use all its features at the moment. So hopefully you're all familiar with it. So taking a step back, really, and this relates to when we proposed this project, it seems a few years ago now. What was the need for it? You know, what was the driver that we thought was behind the need for a tool like thermos? We were aware that cities need to plan their thermal energy networks in a more consistent way than is currently being done or was currently being done. At the moment, it seems like there's many different methods used by many different consultants. There's not much consistency across that, and we then identified this need to try and introduce a tool which tries to pull all that together a little bit, which is very accessible to specifically local authorities, but other stakeholders as well. So the problems that we identified that local authorities were facing is that typically energy master planning and heat mapping studies, they're very expensive. There's also, I mean, certainly in the UK, there was limited capacity within the consultancy sector. The UK government actually has had a rolling scheme of supplying grants to local authorities to undertake these studies. So there was a lot of them going on and only a limited number of experienced consultants to undertake them. So there's a little bit of a capacity issue there. And of course, a lot of the local authorities themselves don't have the capacity in-house to do them. You know, they rely on external expertise and skills to guide them and do the initial pre-feasibility study. I mean, that varies to some degree across local authorities. It depends on how well resourced they are and the size of the local authority, etc. And yeah, as I said, there's just seems to be a lack of consistency of the methods that are used, which then makes kind of meta-analysis quite difficult. So, you know, when you're comparing all the different studies, say, you know, and the outputs, certainly across countries, maybe, you know, it might be a European project of looking at the ways things are done. And so there's different methods used, and this can create problems, makes that kind of high-level analysis quite difficult. So yeah, we came up with the idea of using thermos, a tool which hopefully addresses a lot of these issues. It's designed as a decision support tool for energy planners. We're using state-of-the-art algorithms and methods, certainly with regard to energy demand and mapping and optimization. It's all packaged in a very, what we think is a very user-friendly, open source, web-based application. We think it's certainly tailored to the requirements of local authorities in their citywide energy planning. And crucially, it offers the opportunity to make studies a lot faster, rather than having to go back and forth to consultants to do the different iterations of studies. You know, by bringing it in-house, then local authorities to do the initial bit, you know, they can run many scenarios and get up to speed and just save all that interaction with consultants at time and money as well to start with. So we think that's one of the key benefits of THERMOS. As I said, it's got quite a unique heat mapping, energy mapping facility, very easy to use, as you saw the last webinar, if you join that one. Looks at OpenStreetMap data, which is in most places, and essentially that's all you need at the very basic level to go ahead and use THERMOS. We've worked with Imperial College specifically on developing the algorithms to look at optimization of systems, and we've also worked with other partners such as Aalborg University on energy demand data and trying to validate that into our model. And again, very importantly, as part of THERMOS, we're working with 8 what we call pilot and replication cities. So we're working with actual local authorities in a what we call an agile development method, where we're working directly alongside them. They are actually inputting to the development process of the tool. So they will be the sort of end users that will use it. And we feel this is really useful because, you know, we're making it fit for purpose, directed at the end users. So moving on to what do people need to do to prepare to adopt THERMOS. So it's all about having a bit of forethought on what kind of supportive environment would be needed to ensure that THERMOS is fully adopted and there's proper engagement. So it just takes a bit of preparation for this. And this is something that, as I say, we've been trialing with our pilot cities, and then again looking at lessons learned from that, and doing the same kind of process with our replication cities as well. So we talk about undertaking baseline replication assessment first, followed by a establishment of a local stakeholder liaison group, and then there's a training phase, followed by selection of a case study, and then getting that buy-in as well in parallel to that. So I'll look at these individually now briefly. The baseline replication assessment, this is really just to look at the situation wherever you're using THERMOS in the city or town where you know, the person who's going to be using it is based, and it's finding out more about the framework conditions within that area, and also to some degree what the national framework is regarding energy use, because that sometimes has an impact. So this kind of thing looks at just heating and cooling across the city. You know, what's going on? Are there any existing networks? What kind of demands have we got? Also, what data is available? What's the target set in local policies? You know, how would district heating feature in that? Does it feature as yet? That kind of thing. And also at this stage, looking at identifying your stakeholders and how you might engage them. Looking at barriers and opportunities specific to the location you're in. There might be unique ones there to your city. And just starting to think about a THERMOS case study to focus on a particular area which would be best suited to begin the analysis. You know, an area that maybe has been earmarked before as being potentially suitable for a heat network. So those are the kind of things within a baseline replication assessment, which is really one of the first steps that you would undertake. Then looking to establish a local stakeholder liaison group. Again, this is really key, just to get all the right people on board, whether that's within the local authority or beyond the local authority as well. Just get people engaged, get them in at an early stage, and establish some sort of group, defined group of stakeholders that are aware of Thermos, and they've got a number of advantages to do that. It can facilitate data collection across the city. It can promote capacity building, and you can introduce individuals with new skills and expertise as well. And it's a two-way process as well. Not only, are you've got the opportunity to get data in from that group of people, but also you can communicate via that group of people, send out the right messages as well. There's a future module that we'll be doing as well. It's going to be pre-recorded, which is specifically more about stakeholder engagement. So yeah, keep a watching brief on that. So yeah, engaging trainers and rollout of training. So I mean, this really is what we're doing at the moment. We had a initial trainers program about a year ago that was more restricted to the partners of the project, but this one now, this is webinar 2 of this program, it's looking at wider participants. So there's going to be this network of trainers who are familiar with Thermos, and we're also recruiting ambassadors who are organizations with nominated individuals who can disseminate Thermos. They can learn about Thermos. They can go on this trainers program and just raise the awareness of Thermos and add and help other people who want to take it up and who are interested in engaging. So there will be a network of people who know quite a lot about Thermos, and so it's important to tap into that for any local authority or other stakeholder who wishes to adopt Thermos going forward. There's a lot of materials that we're producing which will help that. Things like, I mean, there's obviously publicity materials such as Thermos Flyer, and there's a set of capacity modules which we produced last year. They're available on the website, and there's also an innovation catalog, series of training videos. Yeah, there's quite a suite of materials now that some of them still being completed, but they will be available for people to use in spreading the Thermos word, so to speak. So the next part was just selecting an initial case study. So this ties in a little bit to one of the exercises that we'll be asking you to undertake as an option at the end of this webinar. So I won't say too much about that, but at the moment, just to say there's generally 4 use cases that Thermos has been designed around to address. And you can see them there, just things like whether you're looking in existing network and you want to expand that, or whether you've got an existing energy source and you're looking at a demand to meet to be served by that energy source, that kind of thing. But we'll talk a little bit more about that in a minute. So where does Thermos fit? So this sequence here is typically the processes that people go through when they're looking at a heat mapping or energy master planning kind of study, looking at network options, going from heat mapping up through to commercialization. And we think that Thermos can certainly help with those first 3. It can, as I was saying, it can bring this in-house without recourse to consultants, or depending on the resources that you've got to put into this to learn about the program and use it. But yeah, heat mapping, energy master planning, and high-level feasibility as well. You know, all this can be done within THERMOS. A little bit here as well about data. What does THERMOS need? Again, you'll be somewhat familiar with this. Some of you will from the first webinar. But just to give you a flavor here, at the very, very basic level, I mentioned OpenStreetMap before. That is that is all you need to start with, really. OpenStreetMap covers most cities, certainly across Europe. It's a little bit sporadic in places. It doesn't always include every building, but all that information is within THERMOS, and basically, as you saw like 2 weeks ago, you can select an area and THERMOS does the rest. It will import all that information from OpenStreetMap and interpret it into polygons, which are buildings and roads and connections, etc., ready for you to start analyzing in THERMOS. And as you can see, that's one of the first key THERMOS processes there, is to create that local map. So on a very basic level, that's all you need once you've logged on, and you can produce a map using that information. Alongside that, we strongly recommend that LiDAR data is also introduced. Now, this describes building heights, and it's variable in terms of its availability. I think most big cities do have this information available, this data set. It's a data set that we at CSC would put in on request. It's not something at the moment that the user can do within THERMOS, but the thing with LiDAR is that it allows the program to calculate much better energy demand estimates, because it will then give an indication of the volume of the buildings, the form of them, rather than a kind of two-dimensional estimate. This then introduces a three-dimensional estimate, so you get more of a refined energy demand estimate. The next level of information is any local GIS sets you might have, and this is quite flexible in, you know, you don't have to use these because the program will estimate them or come up with defaults. But if you do have them, for example, you want to add polygons, buildings into your map, say for new development, you'll be looking at heat demands, potentially local real heat demands, which you want to introduce instead of the estimated ones from the program. You can upload those as well as energy benchmarks. So there's a range of GIS data sets that you can use, and there's a fairly flexible, user-friendly import procedure to do that, which we will be explaining in a future instructional video. And also, just to have a little bit of knowledge about some local variables such as heating degree days and any local costs that you might have. Again, the program assumes a set of defaults for these, but if you did want to change those, it's very easy to do so. It's all very transparent in that way. And then once you've created your map using some or all of that kind of data, you can then start configuring your network options and optimize the network under certain scenarios. So that just gives you a quick overview of what you actually need practically to start using THERMOS, apart from a computer which is connected to the internet, of course. And gathering political commitment. Obviously, a key point of just getting buy-in from the key people who need to make a decision on adopting THERMOS and make it work and truly embed it within the organization and enable it to influence policy as well. You know, we think that's key. Local targets, local plans and policies, and some examples there of the CAPs and CCAPs that some cities, a lot of cities are signed up to. So yeah, it has a real opportunity, it has a real potential to as a tool to help influence this by suggesting the best options for heat networks, which, as we know, have a lot of potential in reducing emissions for cities. In terms of getting organisational commitment, it's important to have an idea of the resources that you need to use THERMOS, and our recommendations is that yes, you get that senior level buy-in and there's a formal adoption of it. It truly gets embedded within the processes there within the organisation. You need to involve IT services as well. Although it's an open source web application, to get IT involved is useful because there's some GIS aspects to it as well, if you do need to use those, and also to have a kind of nominated owner of the tool who coordinates things, who knows about the tool, and who's familiar with it, and any updates, that kind of thing, just to have that role there with a bit of responsibility. Yeah, and organising training around that as well if needs be. I've talked a bit about skills required regarding GIS, which is a sort of an optional thing, I guess, but most people would want to use that. But there's also a basic level of knowledge needed about energy, which local authorities do have people with this level of knowledge, obviously, who would use THERMOS, and just a bit of knowledge about building demands, emissions, that kind of thing, the units used, the KPIs, and it's all fairly standard stuff, but just to have that level of knowledge so that someone, it just gives an advantage to using THERMOS to start with. Just bear in mind the training requirements going forward once the project finishes, then, and to sustain THERMOS and its use across local authorities, having that internal training, you've got as I was saying, a suite of materials to draw on, and so it's making sure that they're put to best use within the organisation on who gets trained up to use THERMOS and how that is done, and also looking at who would be involved in using THERMOS across a local authority. So we all know what THERMOS is trying to do and the influence it has, and the benefits, and we don't need to convince anybody here, I think, about the need for climate change mitigation, but on the grander scale of things externally, this is what we hope THERMOS will achieve, certainly with regard to lowering emissions through use of more efficient heat networks rather than individual boiler-based systems. Go into security of energy supply, where you've got decentralized generation and distribution of energy. There's a range of socio-economic benefits as well. It overlaps with, certainly in the UK, the concept of fuel poverty, where you have the potential to offer lower cost energy, and again, security of supply, that kind of thing. And yeah, it's just looking at the synergy between local energy sources and demands, and making maximum use of those. Internally, to an organisation, and we keep coming back to a local authority where this would mostly be used. We think, as I was saying, it's a cheaper way to do the initial part of the feasibility studies. It can build capacity within that organisation. It's a much more efficient, it's a faster process. You can use it iteratively to run many different scenarios very quickly, and alter things, tweak things to your liking. You're just building this capacity of knowledge about heat networks within the organization as well. And yeah, you're demonstrating innovation as well as a local authority, as an organization in energy system planning. So there's a lot of benefits there for an organization wanting to take on THERMOS. Going back again to cross-departmental potential. So this is thinking about, yeah, across a local authority, who might be involved, and this is very dependent on the type of local authority, and they do vary a lot. Even, you know, in the UK, they vary a lot across local authorities, big ones, small ones. They have different types of teams. They have different resources within those teams. But the main thing here is to avoid that kind of isolated approach, or we call silo approach, where departments are working independently of each other. You've got to make sure that all the people that need to be involved are involved, and that the communication lines are open from the start. And so just a few examples of which departments might be involved. There's obviously spatial planning department, looking at the high level sort of strategic infrastructure that's needed. There's housing, building management, who are the, you know, they could be on the front line, actually out there talking to home occupants, for example, and getting views on heat networks, just that liaison between the end users. There's teams that are involved in sustainability and environmental protection. So, you know, they're interested in the sustainability aspects of THERMOS and what it can trigger, what it can achieve. There's a whole range of things there. Engineering, of course, when you're getting down to the detail of proposed pipe routes and costs as well, and the actual works that are needed, engineering works. There's energy management, which can be a department on its own in some cases as well. So they can help with knowing more about the energy faculties of a city. So where potential waste heat might be if you wanted to tap into existing energy sources. And also feeding back on demands, you know, that local knowledge about what the energy demands would be, not just annual demands, but, you know, looking at a profile of the demand over a year, what kind of time-based demand you'd be looking at, what kind of curve you might be considering. Waste and water management. They could be involved certainly as a potential heat source through anaerobic digestion plants or treatment of waste. You know, there's energy potential there, energy from waste plant systems. Economic development, that kind of relates back to the wider socio-economic benefits I was mentioning that would be realized through locating a heat network in a certain area. And of course, energy procurement, where you're comparing costs, existing energy costs, with those modeled by THERMOS. And finally, yeah, social services. Again, they're again on the front line, liaising with maybe social housing occupants. So, you know, they could be talking to people about a potential network in their area at that time. Transport mobility teams, they can be involved in the infrastructure and routing pipes, and you know, looking at roads and what structures are there, what utility infrastructure services are there that need to be aware of if you're considering running a pipe down a certain street, for example. And IT services, as I mentioned, in terms of GIS formats specifically, and optimizing THERMOS in the sense of giving it the best possible local information to override the defaults. You get increased increased useful outputs in that sense, is where you can maximize the use of your local data. So yeah, THERMOS is open source. It's an open source tool. It facilitates multi-stakeholder use by a number of ways. It's just kind of going over a little bit to what I've said before. It's using common data sets wherever possible and making that flexible for the user to use their own data sets. It looks at it brings in a certain level of consistency across studies, so that other people can then start comparing outputs and different projects. That's very useful for, for higher scale studies, and yeah, a lot of support through different project outputs that we've put together so far. It is not just for local authorities. There's a list of people who can potentially use it there, ranging from, central government, civil service, consultants can use it, could be utilities, community groups as well to some degree, who certainly in the UK, who can now be involved in the planning system through something called neighbourhood planning groups. It's something they could use to look at the potential in their own area. Others, public sector bodies, where you've got suitable heat demands, and also housing associations. So, there's a range of stakeholders that can end up using THERMOS and would find it useful. So that pretty much comes to the end of the presentation part of this webinar. Just to summarize very quickly what we've looked at. We've looked at how THERMOS can strategically plan networked energy systems more effectively and efficiently and more rapidly. It's a tool that has state-of-the-art algorithms and mapping facilities. It's open source, and it's very user-friendly, we hope. We've looked at ways to prepare for the adoption of THERMOS through a baseline replication assessment and forming a local stakeholder liaison group. It uses open source data as far as possible and allows local data to be used as far as possible as well, and makes that as easy as we can to have that facility to introduce that local data aspect. We've looked at the importance of getting that formal corporate buy-in and looking at the resources that are needed in order to adopt THERMOS. We looked at the benefits of THERMOS, both kind of higher level external benefits and more local internal benefits to an organization. We've also looked at the issues around cross-departmental collaboration to make sure that everyone who's involved or who should be involved is involved, and that there's a process there for keeping everyone up to speed and working as a big team. And yeah, and the last thing was to emphasize that it's very flexible. It's a tool that is there. It's a web-based tool that anybody can access. So although it was designed specifically for local authorities, it's a tool that many other organizations can use as well.